All right. Well, hey, everybody. This is Cosmic, and you have reached Astronomy Daily Live. This is a daily live stream starting at 2 hours UTC every single day. And yeah, we talk astronomy here for an hour, hour-ish, something like that. Maybe a little bit more, depends on the company and depends on the conversation. Um, so this is a gathering of friends, just just like a circle of friends coming together every day and talking astronomy for a while. Um, and it can be astronomy, it can be space, it can be science almost in general. Astronomy is a very broad science. So um, astronomy is sort of the study of everything. It's the study of the subatomic and the cosmic, and so it's a study of everything. So there's a lot that can be talked about, a lot that can be found out. There's a lot of shit that we don't know. There's a lot of stuff that we think we're pretty sure of, and uh, being a skeptic, being the skeptic that I am, uh, it's like, well, okay, that's that's pretty good. That's pretty good, but who knows? So this is uh, I'd like this to be a skeptical but open-minded discussion about all things astronomy, and we can, you know, get into speculation. We can get into experimentation. Um, yeah, we can cover everything. So this is for everyone. Everyone is welcome, whether you're new to astronomy, or you've been an amateur for a while, or you're an advanced amateur, or if you're a pro. Definitely want everybody to feel free to come in, sort of come and go as you want. That's one of the benefits, I guess, to having a daily show like this, is that there's not a lot of pressure to try to cover topics, and because you have to hurry because you only have you know an hour, and so want to do away with all that. Very casual, yet I hope interesting and stimulating, and hopefully moderately intelligent, very respectful. Um, yeah, just open-minded, open-minded, and yeah, everyone is welcome here, including the kitties. You can see an ear. You can see a couple ears. You come up here almost every night. Pretty much the same time. Just when I start talking, starts coming up. It's like, why is he talking so much? He doesn't talk like that all the time. So what is up with that? Well, I have uh, I have friends in the room here, and when friends are in the room, we chit chat. And so talking astronomy, gonna cover an hour's worth of stuff. Let me pop over to the chat, see who's around. OMC Triple X hanging in there. Thanks for coming in. Now you've got this thing all twisted up. Because if you try to run fast, you're gonna rip that thing out of my hand. So yeah, thanks. You've been here from the beginning. It's been a few weeks now. So yeah, time flies. It's pretty awesome. And Uncle Bill, I think you came in maybe week and a half ago or something like that, and always glad to see you here and elsewhere. So yeah, that's very awesome, very awesome. Uh, Howdy to all of you who are viewing this in the future. So hello from the past. All is pretty well here. Got the I got the hydrogen hydroxide again. Yeah, kind of a it's a relaxing night. I don't need to get up, uh, or I don't need to stay up. So although I'm thinking about doing another live stream uh, from the telescope uh, soon. I can do it here locally. It's in the mornings, and the moon is past full now, so it might be a little bit more interesting to look at. But I guess I'm hesitating a little bit, and I've got the itches tonight. Sorry about that. Um, I sort of hesitate to do that because going going to it's not a huge amount of effort because I just have to walk right outside. So it's not as if I have to go anywhere. I don't have to pack anything. I just have to move. I just have to move things. Right? I got to move that. I've got to move a computer. I've got to move this computer. And you know, just to look at the moon. I don't know. I don't know. Yeah, not a very good view of the moon either. So yeah, I think yeah, I'll have to keep thinking about that a little bit. Just just wanted to give you all a report. Um, uh, Yesterday's words 04. So from the 4th of February yesterday, the what I've done is I've sorted it. So I said the word I 252 times, and that was the most used word. But I look for sort of the first scientific or astronomical word, and haven't found it yet. Haven't found it yet. It's coming. Oh, there it is. So the most used astronomical or scientific word that I used yesterday, I used it 17 times, and in fact, it's probably 18 times. Uh, yeah, 18 times I used the word astronomy, and that is the scientific word, astronomical word that I used the most yesterday. So yeah, this is seriously nerding out, but it's kind of interesting uh, for me at least. So got I guess you have to put up with it. This is but I'm sort of doing this on purpose as well because it's it is scientific inquiry. I'm I'm scientifically interested in what I'm doing here, but I haven't seen anything to sort of grab onto yet. So the process hasn't begun yet in terms of doing something with this, but I'm gathering information. I'm at the first stages of the scientific process. So hey, I wanted to give a huge shout out to a YouTube channel. Um, his name is Gilles, and he's in Montreal, Quebec, Canada, and he's a radio guy. He's a shortwave, mainly I think shortwave radio guy, and he has a live stream show where he sits around for minimum minimum like 3 hours, 3 hours, and just talks shortwave radio. Yeah, and it's awesome. I watch I don't watch a lot of YouTube shows, but I think I watch enough of them to have some favorites. And his show is definitely the kind of show that I would like to have, and it's a lot like this. It's very casual, but he really knows his stuff. He really knows his stuff. He's a computer guy too, so he's up on all the technology and can does have the ability to speak at many levels when it comes to radio. So very awesome. His I will include a link to his YouTube channel. Um, but let me see if I can let me see if I can get the name of it at least. Just at least. Because I don't know about you, but when I hear somebody suggest, especially like a YouTube link, and they say the name, then I can immediately sort of go over and look that up. Okay, I think it's called Official SWL Channel. Official SWL Channel, and that's Gilles, and he's very awesome. He has a cat that you know is there on the show too, and together they make a great pair. So yeah, big shout out to Gilles. I did inform him about the show, and he expressed an interest. But these kinds of things, I think I'm becoming aware. You sort of have to remind people just on the edge of comfort. So I definitely don't want to be annoying, and post a thing even every day. It just seems a little too much. Um, uh, I definitely tweet these things and Facebook them and all of that. But yeah, bothering people, bothering individuals, I'm not particularly interested in that. Here, I'm gonna fix the situation really quick. I'll be right back. All right, well, cool. So there's the shout out. Um, I guess the most exciting thing on my mind right now is the Falcon Heavy launch. Um, oh, by the way, Uncle Bill, I'm still looking at that video about with the line in the moon and what is it. I'm still looking at it. The thing that has me a little confused is that uh, first the first frame that the tip of the rocket is into the disk of the moon. The first frame that they show, there is no line. There is no line, and there. If you look at the subsequent lines, or the subsequent frames, um, the it looks like to me, and I've got to look at it a lot more, but it looks like to me that uh, that the sort of the shape of the line, it's not a straight line. It's not even a horizontal line. It's got some kind of a bend right at the tip of the rocket as well. Um, but the thing that really has me bothered the most is the fact that that first frame, the first image, with the tip of the rocket clearly, overlapping the disk of the moon. It's in the orange part of the moon. Okay. Um, there's no line there. There's no line, and there should be, because if you compare it to the other frames where the line is, you should be able to see that line. So I honestly, at this point, it's not something intrinsic. It doesn't seem to be anything intrinsic to the camera, like the optics or the detector. I I'm not. Nothing's coming to mind that would do that. Um, Now, if if that first frame did have a line there, then I would question his statement about it being wires. Just holding the rocket up in maybe 3 places. So you see one going out that way and one going out that way, and one that maybe you can't see because it's coming at you. So it's going down like that, but the other two look like they're sticking straight out. Maybe, maybe. It's hard. It's really, really hard. Or maybe they're attached to something, you know, just horizontally from them, at that level. I don't know. I don't know. But the fact that the first frame, that first image, doesn't have a line through it, that's the thing that's got me really bothered about that whole thing. And, you know, when I watched it last night, there were like 2,600 comments. So, this guy's a popular dude, so he's going to get a lot of comments. And there's no way that I can read through all of those, or even some of them, um, uh, to see if anybody, has any good ideas. I started looking through the first few, and it's like, there was nothing useful there at all. So I'm hoping, and I'm sure that if they come up with an explanation that or a set of explanations even that sound reasonable, that'll uh, that'll help the rest of us who are pretty interested in that, because as I said, if that first frame would have shown that line, then I would have said, oh, it really looks like wire. It really, really, really looks like wire, because it doesn't change shape. It looks like there's a bend at the top of the rocket, maybe where the wire's attached, you know, or the apex, right? It's the apex. Um, so yeah, I guess at least for me, mm, it's definitely, I rule out anything optical or with the detector. Yeah. Um, I think one of the comments that I did read was a question, and that was what I think in the video there was a second camera. I'd like to see what that second camera saw. Um, and you think about that, it's like, okay, if it also sees the same wire, then does that help us at all? And mm, because either way, well, yeah, just yeah, I don't know. I don't know. It's an ongoing quest for sure. Let me pop up the chat here. I've been neglectful of the chat. Oh, there's all kinds of writing. Yeah, Uncle Bill. Check out Gilles. He's awesome. He's really, really awesome. And I'll make sure to post the. Well, here I can do it right here in the chat. I can do it right here in the chat. So it's let me find him again here on my list, because he's got two channels. He's got a shortwave channel, and he has a sort of a Windows help channel, which is for being Windows, it's actually pretty good. But it's him. It's him. He's very passionate. He's very excited about what he's doing, and he just makes things really really cool. Now, of course, I can't find him now. I found. Oh, there it is. So official SWL channel. I will copy and paste that into the chat. Being the king, I can do that. Yeah, well, you know, scientific inquiry is voluminous. There's a lot that can be done with a simple question like that, right? So yeah, bring it on. I mean, it allows him to to show a lot of people the process of scientific inquiry, and you know that kind of curiosity is infectious. You know, you start doing that and showing uh, that in a live way. That's infectious, and maybe that'll help um, people start looking around a little bit more and realizing how incredibly awesome all of this is, and what's the problem. There is no problem. So, but more people need to realize that first. uh, it's not going to take everybody, though. It's just going to take a few. But yeah, I'm anxious to hear what the explanations, the plausible ones, are that they sort of extract from all the comments and replies and all of that. So I can imagine. I haven't gone back to see how many comments there are now, but I can imagine there are quite a few. Quite a few. Cool. All right. So yeah, I think the most exciting thing that I'm thinking about at the moment is the Falcon Heavy launch. It's it's always exciting to see the first thing, um, and really, really, regardless of what happens, it's uh, it's going to be spectacular. And for some reason, my intuition, my intuition is saying that it's going to launch, it's going to deploy, and it's going to land, and that's it. That's all it's going to do, and you know that's it. So I hope so. I hope so. That's what my intuition is saying. So the other strong intuition I have is that something will make them not launch. Um, something at the last second. Because I mean, this is new, and yeah, that's the hardest one. Definitely the hardest one. But yeah, so I'm most excited about that. I don't know if you saw they came out with a press kit. Apparently, I saw this on the Twitter sphere, and it's probably more pages than just one. But what I've got is a timeline, a mission timeline. So I'm not going to go through this all. Um, they they lift off, and at at 2 minutes 33 seconds, the side cores separate from the center core. The center core continues to burn through this whole process. So the two side ones, they burn out first and drop off. And then the center core keeps going. The center core separates from the second stage at 3:07. So at 2:33, the side cores fly off. And at 3:07, 3 minutes, 7 seconds after launch, the center core separates from the second stage. And then, of course, the second stage fires and delivers its payload to orbit or to whatever trajectory is determined. So that's launch and deployment. And deployment comes actually later. Deployment comes, well, it doesn't say here. It says when the second stage is going to cut off, and that's at 28 minutes, 52 seconds. I thought there was a third stage too. I heard something about a third stage to get it into hyperbolic orbit, which is just a hyperbolic trajectory from Earth. It's not sun escape. So apparently it's going to be put into an orbit around the sun, a heliocentric orbit, which will have either as an apogee or a perigee or somewhere in between around the orbit of Mars. So that's a great and very clever PR stunt, and I fully endorse it. I still am not, it's the skeptic in me. I'm still not sure that that's what's in there. I think it very well also just could be a block of cement. So, because that's not a lot of weight. And I would think that they would want to test this with some serious weight, maybe not max weight, but at least half, if not a little bit more, push it 70, 80%, 90%, just a big chunk of concrete would do the job. So not too, I'm still skeptical about the whole car thing. So, but if it is, hopefully it survives launch. That's really rough, and then it's got to survive being out in space, and that's really rough. So we'll see what happens to it. I hope they have some cameras. I hope they, um, even if they don't show it live, I hope they record what happens. You gotta think that they're recording it, because if it's something interesting, something PR-ish, you know, um, then they're gonna like it. Anyway, so deployment happens, whatever it is, and that goes on. Meanwhile, three events have happened. At 7 minutes and 58 seconds, the side cores land, and at 8 minutes 19 seconds, the center core lands. So we're going to have three rockets landing, within 23 seconds of one another. Two sort of simultaneously, and one 23 seconds later. So that's gonna be pretty epic. But so either nothing is gonna happen at all, and they're gonna have to postpone it, or something very exciting is gonna happen. And and that's two kinds of exciting, right? One kind of exciting is boom at some phase. The other kind of exciting is the one that I have an intuition about, and that is launch, deploy, and land, or launch, land, deploy, however you want to put that order. So yeah, I think that's what's going to happen though, and that's it. They're going to launch. They're going to you know get their cargo deployed, and then they're going to land, and that's it. Everybody will cheer, and then we can move on. We have some new capability, and it's finally from an entity that is going to get shit done. So I'm totally in favor of getting shit done when it comes to uh, uh, expanding our choices. You know, we're stuck here right now, and that's ridiculous. That's ridiculous. Why should we be stuck here? That's stupid. Stupid. It's all we have to do is want to, and we can do it. So let's do it. And I'm glad that somebody is finally, the right place at the right time with, they're just all the right kinds of resources, and is going to do it. So awesome. I'm all for it. Let me get back to the chat here. I've been neglecting the chat. Yeah, I saw, I didn't see the animation, but I saw that it had been posted. Um, yeah, okay. I will have to watch the video because it's sort of, Uncle Bill, from your first thing there about heavy metal. That sort of implies that they did have a simulation of the deployment. Is that true? Small hypergolics mounted on the Tesla structurally. Mm. Yeah, that's the other thing about the boom, right? If it's a boom on the pad, then your pad is screwed, right? And it's going to be screwed for a long time. So I think there was a comment from Elon about that, and he said, yeah, but it's not going to stop production. So yeah, you won't be able to launch, but you'll have your rockets ready. So okay, but doesn't seem to be too concerned about destroying the most famous uh, launch pad on the planet. Doesn't seem too concerned about totally destroying it. So it just built it again. Yeah, I guess you can do that. You can do that. Um, Hypergolics mounted on to the Tesla. Structurally, the Falcon platform can't handle extra length. Okay. Falcon hits structural limits when they realize that the tanks for full thrust superchill version, traditional third stage, is not an option. Okay, okay, that's cool. Yeah. Well, we'll see. Pretty exciting. I think the at least the news report that I saw, and you all can correct me if I'm wrong about this, but what I saw was, oh, where's that article now? That's not it. It's here somewhere. I thought I had it up here still. Yeah. So I guess the launch window opens at 1830 UTC, 1830. So I'm 7 hours behind. So that puts it at 11:30 a.m. here. So, whew, and I guess the window is until 2100 UTC. So that's like 2 p.m. where I'm located. So 11:30 to 2 is the window. So we'll see. We'll see. The weather looks good. The rocket looks good. As I said, it's a little strange. The test seemed a little short, but if they think that if they're pretty confident with the engines themselves, because these are just Falcon 9s, right? 3 Falcon 9s. If they're pretty confident with the performance of those engines, then it's all you really need to do is make sure they turn on. So you flip the switch, on, off, and that's sort of what they did. And that's probably enough information, to get enough data to measure all the stresses and all the resonances and all of that. So that was probably enough data. I mean, if they ran for 12 seconds, you can sample a million data points a second. You've got a lot of data there, high resolution. So yeah, they probably got enough data on all the stresses and everything else. And since these are Falcon 9s, they probably have pretty high confidence that they know how they work and how hard they're going to push and how and with when and if and all of that. So they just needed to make sure that they could turn it on, that the on switch worked, right? Because you don't want to flip the on switch and have it not go, or only have one of them go. So yeah, so that's pretty exciting. Definitely want to catch that somehow. I'm going to be at work, so that's going to be challenging, challenging to yeah, but it can be done. It can be done. Spilling water. Oh, I gave it away. I gave away what I was really drinking. Oh, that didn't last long. All right, let me get back to the chat. Yeah, well, that's true. And they've also got Vandenberg, right? And soon something in Texas, or is that another company? I'm sad to say it's almost getting hard to keep track of all the rocket companies. Pretty awesome. So I guess I don't know what direction to take tonight's show. We're really casual around here. Um, been thinking about the CCD camera a little bit more. We talk about working with those. I wanted to continue to sort of run through archive.org, since it too is sort of a daily thing. Us daily types definitely need to stick together. I think I'm getting some lag, so gonna have to put up with that, I guess. Um, but let's just see. Let's see if there's anything interesting new. This is Monday, so they they put out new papers Monday through Friday. So let's just see here. New probe of line of sight magnetic field tangling. Massive survey again. I think I saw another paper about that last time we looked, huh? And the strong. Oh, we saw this. What is? Oh, that's Friday. Oh, maybe they didn't update today, because I was looking at those and it's like, wait a minute, I recognize those from the last time we looked at these, which I think was Friday. Yeah, this is where I found the liquid mirror telescope, the mirror that's made of mercury, and they spin it, form I think they can get it into a parabola. I think they can. Let's see if there was anything interesting else here, because I kind of got on that, and it's like, wow, that's all that needs to be read. I don't even remember where it was. Was it this far down? Did I miss it? I don't know if I missed it or not. I don't think I did. Where did it go? I can do a search and go. Uh, no. Hmm. Yeah, I don't know. It's not here now. Well, all right. It's fine. We can still go through these. Let's see. So H naught is the Hubble constant, or they're calling it the Hubble parameter, which is a measure of the expansion of the universe. And depending on what that number is, it tells you things about how the universe has evolved, at least according to the models that we use. So there's another measurement there, trying to trying to get this number as low as you can, right? Because that's your precision, that's your error. So that's that's getting pretty good. That's getting almost 1%. That's like 3%, something like that. Pull out the handy dandy calculator and divide 1.66 divided by 73.45. Yeah, 2.26%. Wow, that's pretty good. It's pretty good precision. It's not good enough, but it's getting pretty good. A lot of modified Newtonian mechanics these days. Nobody likes nobody likes gravity, Newtonian gravity, and nobody likes and nobody likes general relativity. It's okay by me. We need more ideas, and if it's wrong, it's wrong. Let's move on. Let's figure it out. Don't get hung up on stuff. The nature of the TRAPPIST-1 exoplanets. TRAPPIST-1 system hosts 7 Earth-sized temperate exoplanets orbiting the ultra-cool dwarf star and an ultra-cool dwarf star. As such, it represents a remarkable setting to study the formation and evolution of terrestrial planets that formed in the same protoplanetary disk. So all the sizes are known to within 5% precision. Their densities have significant uncertainties because of poor constraints on the planet's masses. So they got the sizes okay, but not the masses. So yeah, the goal of the paper is just to improve basic knowledge about these guys, and they seem to come up maybe with some more precise numbers. That's all right. Cool. You can get a lot just out of reading the abstract, and you don't even have to read even the whole thing. Chemical analysis of 3 barium stars. Huh. I don't. Have you ever heard of a barium star? Hmm. I wonder if it explains what a barium star is. Let's load it up and read it. This is the great thing about archive.org is that you can sit here and just read these things. It's right there. It's free. Chemically peculiar stars such as CH stars and barium stars that exhibit enhancement of slow neutron capture elements in their surface chemical composition can provide observational constraints for models of neutron capture nucleosynthesis that occur during the AGB phase of evolution. That's the asymptotic giant branch phase of evolution of low and intermediate mass stars. Both the CH stars, which I guess are carbon hydrogen, and barium stars are known to be binary systems with a now visible white dwarf companion. Pretty cool. So a barium star is just that. It's a star that has a lot of barium in it. Yeah, these uh, these are pretty weird. Weird. I, at least apparently, according to this thing, they're kind of strange, chemically peculiar. So they got a lot of barium in them. Hmm. So it's just the same. These all these papers follow the same basic format, right? They have an introduction. They have an introduction which sort of lays out um, uh, uh, that lays out sort of the theories that they have. Some speculation, and then they get into how they collected all the data and how they set up the experiments and what instruments they used, how they analyzed the data. Very detailed stuff. A little bit of math, to show how they're uh, coming up with some of the numbers that they show in their tables here. So this is a plot. Figure 2 is a plot excitation potential in electron volts versus abundance of iron 2 and iron 1. So, okay, it says the iron abundances of stars are shown for individual iron 1 and iron 2 lines as a function of excitation potential. The solid circles indicate iron 1 lines, and the solid triangles indicate iron 2 lines. Oh, I didn't realize there were two different kinds of, whoops, I'm getting ahead. I didn't realize there were two kinds of dots there, but yeah, I see them now. Okay. A lot there's a lot more data with the iron one, a lot more round solid circles. Okay. I don't quite understand what that means, but that's all right. So these are just the spectral lines that they used uh, uh, in deriving all these parameters. Very cool. So they're looking at the atmospheres of these stars, and seeing uh, in this case iron one and iron two. Not sure why they're using iron 1 and iron 2 when they're talking about barium stars. I don't know. There's very weird mysteries like that sometimes perplex me. But this is hardcore spectral analysis. So they're getting these spectra up here, uh, these things. Okay, these things are getting this stuff, and they're making all kinds of measurements on here. They're measuring the depths. So this is like a profile, right? It's so, and yeah, that's hard to explain without showing you a picture uh, also. But this is these these are what are called spectral lines, and they don't look like lines here. They look like dips, right? So spectral dips. There's a reason why they're called spectral lines, but I would need to draw you some stuff, and I'd rather show you some pictures than draw. So I'll try to remember to do that. I'll make a note, and yeah. So we can call these spectral dips, and every one of these lines correspond to some kind of atomic activity. Um, Mainly, the electrons are um, gaining and or losing energy. So they're jumping between orbits as they go around, the nuclei of the atom in sort of the orbital model of the atom, which is more of a metaphor than actuality. Nobody's actually seen any of this stuff, so we don't know what it actually looks like. Well, we probably will eventually. So, but they can measure the depth of these dips. They can measure the width of these dips. They can measure the positions where they are, what wavelength they're at. You see, this is a wavelength in angstroms down here on the bottom, and this is just yeah, a relative intensity. So it's not numerically, there aren't really any numbers associated with that. It's just showing that this value is lower than this value, right? Because it's a smaller number. So that's all. Yeah, yeah, you've got it, Bill. I just wanted to show a picture, and I probably will, because this is just, like a single line profile. It's like a row um, in a spreadsheet. But yeah, I think I want to show a picture of that. But anyway, so that's what they've done. They've measured all this shit, and most of this, I would say, is pretty significant. Even the funny things here and all that. Uh, there's at least according to the models, there's a very good understanding of the models, and the models do match the data well enough to give us some confidence that what we're simulating in the models is might be what is going on in these stars. um, so we can measure the actual stars and say, oh, okay, well, if it's if it's if this feature here is this dark and it's this wide, then that means that there's this much stuff of whatever it is. And I think this is marked magnesium 1. Okay, this is a magnesium 1 spectral line. Uh, so you can measure how much of that there is. You can measure its temperature. Um, you can get an idea of where it is in the atmosphere of the star if you have a model of the star. So lots of info there, and that's what really the rest of this is. All these dots and all that is just an analysis of these measurements that they made. Um, and as I said, I'm not quite sure why. They're looking here at the iron 1 and iron 2 lines. So here's iron 1, here's an iron 1. I don't see them identifying an iron 2 in this. So for some reason, they think that measuring iron and magnesium and titanium and carbon um, is going to tell them something about barium. So, I would have to really get into the paper to have a better understanding how they're correlating that. But here's all the analysis part. They go through a detailed analysis, trying to, you know, these dotted lines are probably obvious. They're obvious to me, at least, that there's some kind of model, and then they like to overlay their data onto the model, and see where the data lies, and see if it can represent the shape of these things. If there's any correlation there at all. And this is hard, right? Because looks like there's only 3 data points there. So that's well, those are the 3 stars, and this is the Hertzsprung-Russell diagram. So yeah, they're all going to be about in the same location, and they are. Um, yeah, interesting. Okay, more analysis. Maybe these are zoomed in a little bit, so these are the same dips that we saw before, just sort of zoomed in a little bit. You can see that the wavelength uh, band here has changed, right? So it was, we were looking at some pretty wide band stuff. Let's see. What I like about this daily thing is that it's like, yeah, have fun, relax. So this is like 10 angstroms between here and here, 5170 to 5180. So that's 10 angstroms. And if we look at these, this is about 6 angstroms, so it's about half of that. So yeah, it's just it's zoomed in, and it looks like they're trying to fit various models to the data. The data is usually always the noisiest wiggles that you see on here, and they're just looking at different spectral regions. So this is what they're calling a C2 band. This is what they're calling an O1 triplet. It's hard work. It really is, but this is what astronomers do. This is how they spend their time. You know, they they have to they have to the cool thing is, right, is that this process is really, I mean, it can get really complicated because uh, you have to plan your observations, right? Which means you have to already have some idea what you want to do, what you want to look for, what you want to look at, what you want to measure. Um, then you have to, apply for telescope time and figure all that out. You got to, get the right instrumentation, make sure that you understand the instrumentation. So when you collect your data, you can you know, understand what your data is telling you. If there are any artifacts from the instrumentation, you need to be able to calibrate those out, so it's not interfering with your raw clean data. Then you've got to collect your data, and then you have to reduce your data. So you have to remove all the systematic stuff, all your calibrations, everything in the system that would ruin the quality of the data that you're trying to collect. So you collect your data, and you've got to reduce your data. Then you've got to analyze your data. Okay. And then once you're analyzing it, you've got to write this paper. Okay. And let me tell you, these are hard reads. These are really hard to read, and it's yeah, it's not quite like another language, but it's just, I mean, uh, yeah, there's some complex ideas going on here, some serious mental gymnastics. You have to be able to visualize, and you have to be able to, understand this in order to get anything out of these things at all. But it's nice when you can, when you can pull out even the smallest of pieces. So then they always end up, with some kind of a conclusion or some kind of a discussion, saying what they found out, you know. So, they come up with a question or a problem, and then they say, okay, this is how we're going to figure out this problem. And then they go and do it, and then they report back and say, hey, this is what we did. This is how we figured it out. And it's nice, for the most part. I think they lay it all out. They lay out all their data. Sometimes it's just an insane amount. But as a data artist, okay, as a data artist, I look at something like that, um, with with an eye towards maybe being able to do something with this information artistically. Don't know. And then of course all the references in the back, which are always awesome. More numbers for us. Wow, there's a lot of data here. Lots and lots of data. Good stuff. Don't really know what any of it means, but that's okay. It's can't possibly can't possibly know all of this stuff. It's fun to see what's going on, what's being studied, how things are being perceived and measured. So even sort of mundane, maybe sounding things like this, it's all good stuff, and it's all it's there's a lot of effort. There's a lot of effort that goes into these things, and that in and of itself, really requires some respect, because it's a hell of a lot of effort to go to the kind of work that these smart people uh, are doing. Um, just amazing. It's amazing to be in proximity and in some cases in association with these kinds of individuals, because it's just uh, I'm in absolute awe, absolute awe. All right, maybe I'll get back to me. I'm not seeing anything going on in the chat, so let me get back to me. Wondering if there's any other interesting. Am I back? I'm back. Anything else interesting going on in the world of astronomy wants to be brought up for tonight? Make sure, if you haven't already, to subscribe and get your notifications set. This is happening every single day at 2 hours UTC. It's called Astronomy Daily Live. And every single day at the same time, same place, I sit down with a group of friends and we talk astronomy for an hour, something like that. It's been just over an hour, so I'm thinking about wrapping things up. I got went to the art show at the university and picked up my artwork pieces, and I picked up that. You see it? So that's pretty cool. There were there were there were 12 prizes and 208 entries. So I was in the top 5%. Yeah, not too bad. It's really that whole experience has been very inspiring, and I'm definitely I got good response, nice strong response, and that makes me want to do more of something. So I don't know yet. There's one more thing that I want to do with what I'm doing now, and I'm working on that. But that's actually going to be pretty easy to do. So that's sort of why I haven't done it yet, because it's sort of like, oh, okay, I just need to go through a little bit of the motions and it'll be done. It might be interesting though. So definitely want to get into 3D printing. Every piece of artwork that I create can be made into a three-dimensional object. It doesn't have to be a two-dimensional object. Everything sort of that I've been doing since I started this has been on a two-dimensional surface, and I can make them look three-dimensional, but there's nothing like actually being 3D, something holding in your hand. So I'm thinking that's an interesting uh, possibility to move into, and I have things to make. Definitely have things to make. Might be kind of interesting. Looking into 3D printers. So yeah, there are there's a full spectrum of those things out there. So looking at those kind of hard. Um, yeah, we'll see. We'll see what happens with all of that. But yeah, I'm definitely looking to what I can do next artistically, and I don't know what that's going to be yet. It is going to be using data, but I don't know. I don't know what it's going to be yet. Lulzbot, Lulzbot. Look into Lulzbot. I don't know what Lulzbot is. Should I look it up really quick? Get a drink of hydrogen hydroxide. Lulzbot, Lolzbot, Lulzbot, Lulzbot. Oh, they're printers. Okay, 3D printers. You guys are great. You guys are awesome. Huh. Okay. As I said, yeah, I'm looking around, and probably what I'll do first, right, is I'll make something and have somebody else print it, um, and see how that turns out. But yeah, well, thanks for the link. I appreciate that, Uncle Bill. I will definitely look into them. Yeah, very very cool. Yeah, and I'm a programmer, so I can if I have an API, or if I have like a list of commands, um, any kind of language, I mean, if it has to be um, written in a special CAD type language or anything else, I can probably do it. I can probably do it. So yeah, okay, interesting. Open source hardware. Interesting concept. But anyway, so yeah, that's where my head is these days. It's mostly with Falcon Heavy, for sure. Want to see what happens tomorrow. I think everybody's waiting. Um, so definitely check out Gilles' shortwave radio channel. He's very very awesome, and I like him. And he's very very passionate about what he's doing as well. And uh, I am definitely taking a lot of hints from his show in order to do this one. His is very very casual as well, but it's very interesting, and uh, it's yeah, it's it's a good show. It's a good show. Very informative, very laid back. Um, but he knows his shit for sure. All right, well, I'm gonna get out of here. I'm gonna get back up to the ship where I belong. I can't be away from that overview effect for too long, or I get a little claustrophobic. So yeah, I think I'm gonna exit for now. I will see you tomorrow, 22 hours, 23 hours, a little bit less than 23 hours from now, we will be back here. Maybe we can talk about the launch, whatever you want to talk about. This is a circle of friends, and just sitting around chit-chatting astronomy for an hour or so, sometimes a little bit over, whatever it takes. We're pretty easy. Glad you could come in, and I will see you tomorrow. Okay, have a great day, you guys. See you tomorrow.